Similar to the sigmoid function, the normal cumulative distribution function fulfills the two criteria that we stated in the previous tutorials. Firstly, the function must not exceed the limits of 0 and 1. That is, the probability should always be between these limits. The relationship between the probability of success and the independent variables must be nonlinear in a way that the changes in probability are smaller as we approach extreme values of independent variables. As the sigmoid function is used to estimate the logit model, the normal CDF is used to estimate the Probit model. Hence, the logic behind the Probit model is the same as logit model, only the functional form is different. If we go back to the first example of car ownership as a function of only income, we can express the model as shown here. The probability of car ownership in the case of Probit model can be expressed using the normal CDF. Similar to logit model, the probability is a nonlinear function of z, whereas z is a linear function of independent variables, which is income in this example. We use the maximum likelihood approach to estimate the Probit model. The likelihood function is constructed in a similar manner to that of the logit model with the same underlying assumptions. Firstly, we know that the dependent variable x follows a Bernoulli distribution because it can either be 1 or 0. We already stated the probability mass function of Bernoulli random variables earlier and is expressed as shown here. As we did in the logit model, we can obtain the likelihood function from this probability mass function under specific assumptions. From this probability mass function of single observation, we have to obtain the joint likelihood of all n observations. Under the IID assumption, that is, by assuming that the values are independently and identically distributed, we can derive the joint probability by taking the product of individual functions. This is known as the likelihood function. It is easier to work with log likelihood, so we can take the log of this function to arrive at the log likelihood function. Our objective is to maximize this log likelihood with respect to the parameters of the model. That is, we have to choose the values of beta 1 and beta 2 in such a way that this log likelihood function is at the maximum. Similar to the logit model, we can use iterative procedures such as Newton-Raphson or BFGS to estimate these parameters. The estimated coefficients and their interpretation does not make much economic sense. This is because the coefficients show the change in z-score with a 1-unit change in independent variables. Therefore, we should estimate the marginal effects after Probit model as we did in the logit model. In our car ownership example, the marginal effects will show the change in probability of owning a car with a change in independent variable income. To obtain the marginal effects, we have to calculate the partial derivative of the probability of car ownership with respect to our independent variable of income. As we did in the logit model, we can express this using the chain rule as shown here. The probability of owning a car is a function of z and z is a function of y or income. These marginal effects can get more complicated in the case of Probit model, however, they can be estimated easily using statistical software programs. Even the interpretation of the marginal effects is similar to the logit model. The only difference is the link function because we use a normal CDF in Probit model, so the marginal effects will be slightly different as compared to the logit model. To illustrate the application of the Probit model, we will use the same model and dataset that we used in the illustration of logit model. In the equation shown here, the binary dependent variable is x, which shows the decision to purchase a car. It is equal to 1 if the individual decides to purchase a car and 0 otherwise. This x is a function of 3 independent variables of age, income, and gender. To estimate this model in R and Stata, we can use the packages and commands shown here. You will notice that these commands are exactly the same as the logit model, except that we mention Probit in place of logit. This makes estimating both the models easier. We simply have to switch the link functions in the commands. It is important to mention the gender variable as a categorical variable because the marginal effects will be different if we don't specify this correctly. These commands will return the results of the Probit model as shown here. Again, these estimated coefficients do not have a meaningful economic interpretation. As age increases by 1 year, the z-score of purchasing a car increases by 0.120678. The other coefficients are also interpreted in the same way in terms of z-score. Since this does not tell us anything about the change in probability, we should estimate the marginal effects after Probit model. Similar to Logit model, we can estimate average marginal effects or AMEs, marginal effects at mean or MEMs, and marginal effects at representative values or MERs. In fact, the commands will be exactly the same as the ones we used in the Logit model. The only difference is that we will input the estimates of the Probit model in the commands instead of the Logit model estimates. The commands shown here can be used to estimate the different types of marginal effects. These are the same margins functions as the ones we used in the Logit model. The commands in blue will estimate the average marginal effects or AMEs for all the variables. The commands in green can be used to estimate the marginal effects at mean or MEMs separately for males and females and at the mean of age and income. Finally, we can estimate the MERs or marginal effects at representative values with the commands in black. You will notice that we have chosen the same levels of age and income as we did in the Logit model. We are estimating MERs at age 30 and 60, and income 30 and 120. We have used the same values so we can compare the marginal effects estimates of the Probit and Logit model. First, let us compare the MERs for age. As age increases by a small amount from 30, while income stays constant at 30, the probability of purchasing a car increases by 0.3% according to the Probit model and 0.31% according to the Logit model. Similarly, as age increases by a small amount from 30, while income stays constant at 120, the probability of purchasing a car increases by 4.45% in the Probit model and 5.02% in the Logit model. For gender, at age 30 and income 30, males have a 0.47% higher probability of purchasing a car in Probit and 0.46% in Logit model. At age 30 and income 120, males have a 6.98% higher probability of purchasing a car in Probit and 7.31% in Logit model. As we can see, the marginal effects are interpreted the same way for both models. Moreover, the marginal effects are quite similar for both models in most cases. The differences that we observe in the marginal effects are due to the different link functions used in the Logit and Probit models. Even in case of predictions, both Logit and Probit models give similar predictions in most cases. We will discuss the predictions and classification table in the next tutorial. Thank you for watching, and I will see you in the next tutorial.